瓦上的波霜，窗前的月光，都照亮心底某个地方。有人用思念两段足石行，流淌过1000年，恋恋难忘。你有绿树红墙，寄我这风霜，也有草长白云白，吹到长城长。天水处小巷，早上老火汤，在家3分时光，坐在门前慢慢唱。人间烟火山河浩荡，清风过大江，水路弯弯连海浪，两岸千里的花香。你爱的人啊，记得你最好模样，你是大宝的忠贞，是心之所向。时代滔滔向前，温柔而勇往，留步我梦中的你。哇，we are continuing back. Yes, playing. Not playing. Doing coding challenges. Hello, Simon. We are walking through the stack patterns. So, decimals to binary conversion. Given a positive integer n, write a function that returns its binary equivalent as a string. The function should not use any inbuilt binary conversion function. Binary equivalent of 2 is 1 0, 7 is 7 1 1 1, 18 is 1 1 0 1 1. I think I believe input 3 would be 1 1. And then 4 will be 1 1 0. We have to convert to binary. Number to binary. There must be a pattern. So 0 is 0, 1 is 1, 2, 3, 4, 5, 7. Oh, what's the pattern here? Hello. So if we convert decimal to binary, if you take 1 divided by 2, remainder is 0. Remainder is 1, divided by 2 is 0. And if it's 3, divided by 2 is 1, remainder 1. So 1 is 3. If 7 divided by 2 is 3. What's the pattern here? What's the pattern that relates to stack? So if we take 18 divided by 2, 18 divided by 2 is 9. Remainder is 0. 9 divided by 2 is 9 divided by 2 is 4. Remainder is 1. 4 divided by 2 is 0. 4 divided by 2 is 2. Remainder is 0. 2 divided by 2 is 1. Remainder is 0. So 1. Now what does this have to do with stack? So let's see. While num is not equal to either 1 or 0. Num is not equal to 0. Num is equal to num divided by 2. Remainder num divided by 2. So 18 divided by 2 is 9. Remainder. So remainder is equal to num log 2. And then we push to stack. Do we even need to push to stack? This is more like shift to the stack. Because 0, the first remainder will be the last item. Remainder, and we also have outputs. We're going to set output to nothing right now. So outputs will be equal to outputs plus remainder. I believe this just converts this to string because the thing is set to string. Right, and lastly, we just have the whatever num that's remaining. Oh, actually, if num is 1, if num is 1, then outputs equal to output plus num, and then we just output the num. Output the output. Hello. Hello robots, Blue, Leon. We're just doing codings. Out of memory. So this is doing an infinite loop right now. Oh, cause this is a we need to do a math dot floor of this value. Otherwise, it's never gonna be 1 or 0. I mean, not never, but like, eventually it's gonna be become a decimal. So you just dividing decimal by 2. Run this again. Out of memory. Well, num is not 1 or num is not 0. Remainder is num mod 2. Okay, let's test case is 1. Test case is 1. So while this doesn't even run. So if num is equal to 1, output is equal to output plus num, and then we just return output. So why would this be out of memory? If num is equal to 1, output is equal to output num. To console log outputs empty. If I remove this 1 again, it's 1, right? So while this not equal to 1, so this gets me into an infinite loop. While num is not equal to 1, or num is not equal to 0. And num is, I think that was done. Run again. I made it. Okay, 2. Okay, let's see. So it's 2, then remainder num mod 2 is 0. And then num math float 2 divided by 2 is 0. Remainder is 0. Math is okay. This num is 1. Num is 1. So output is now equal to output is 0 right now, and then 1 plus oops. There. Why? 5 is remainder is 1. Yeah, it should be 1. It should be 1 here. Why is that? So 5 as test case. And then we're gonna put the console log here. Then run this. Right, remainder is 1. Oh, what did this? Ah! I just reminded myself and then I fucked up again. It's reverse order. Submit. Okay. But this has nothing to do with stack. Yeah. So they did stack. Hold the stack. Push this. And then num is floor. And then you join. Stack push to the first one. Oh, they push and then they did reverse. Oh, didn't know JavaScript as a reverse. JS array reverse. Oh, no, something I've learned today. There's a reverse function here. Yeah, I didn't know there's a stack function called reverse. I guess okay, that makes sense then using stack. So what we're gonna do is just have we make a stack anti-array. Wait, how did they stop this? While num is greater than 0. Oh, cause the last one. While num is greater than 0. So they do is stack dot push num divided by 2, and then num is math float num. And at the end you just do stack dot reverse and then going. Oh, that's much shorter. Okay. Next. Next greater elements. Given an array, print the next greater element for every element. The next greater element for element x is the first greater element on the right side of x in the array. Next greater is on first greater element on the right side. Elements for which no greater element exists, consider next greater element as -1 on the right side. Next greater element. So in this case, 25 has no greater because this is the last index, so you have a -1. And 2, the greater than 2 is 25. So you put 25 here. Next greater. So we're working with 2 stacks. So basically working with 2 stacks. And then after this is done, we push it to stack. After this done, we push stack. And then we look at this, and then we look at the stack, pop the stack. If this is less than, we pop the next element. And if the stack is empty, then we just return -1. Okay, I think I know what that is. Let stack is equal to nothing, and then while array dot length result, if we resolve in -1. You don't need to do that. I can create a result, empty array. If stack dot length is equal to if the length is 0, then we push rest.push -1. If it's 0, we push -1. Otherwise, the current element that we're looking at is array.top. And while the element is this, and then while stack dot length, if the current is less than stack.pop, we still need a placeholder. Top is equal to stack.top. Right? If current is less than top, then we push top. Rest.push top. Otherwise, break. We'll push top, otherwise we update top to stack.pop. While live. If this is top, then we break. Otherwise, we keep popping. So then the push -1 should be at the end. So in the end, we do a reverse again. We do a reverse and then it's return the reverse. Run. -1, -1. Array door length. So current array pop is 5. And top is stack.pop, top is undefined. While stack.length, there's no stack.length. So stack.length is 0, so we push 1. Oh, I see. Because we are not modifying the stack here. So after we push 1, we should also... After we push the rest, we should also stack.push whatever the current number that was popped. Stack.push. Well, if I'm doing this on both ways, I just do it outside then. So we push to the current number. Run this again. Still -1, -1. It's been 84 years, something like that. Yeah, long time no see. Okay, so array.pop is 5. Top is undefined. While is nothing because the length is nothing. If stack.length is 0, then we push 1. And then we stack push the current. Current is 5. Like console.log. Stack and rest. Stack is 5. Rest is -1. Okay, so the next iteration, current array.pop is 4. Top stack.pop. Oh, okay, I see. Stack.pop. This is removing the 5. So we don't need to remove 5. So in the real way that so I shouldn't be modifying the stacks full 5. Since I'm looking here, So 5 has nothing to the right side. This is -1. 4 has 5. But if I'm pushing 5 into the stack and then popping that 5, after 4-5 compare is done. After 4 compare is done, 5 is gone. So instead of copying stack, I just look at the index. So if I look at index here, first we look at index +1. If it's greater, then we push. Otherwise, we keep looking at index to the right. So we go in this direction. So 5. If it's not greater and then we are out of bound, then we push -1. Okay. For let I equal to array.length -1, I less than I is greater than or equal to 0, I minus minus. Let next equal to I +1 if actually while lex is greater than or equal to, well, next is less than array.length. Next ++ if next is greater than array.length, greater than or equal to array.length. If it's greater than we rest stop push -1. Else we do a compare if sure, we don't need to do else. If this is that, you push and then this will break out. Yeah, it's better to have else. Else we compare the current index, which is array I. If array I is less than array next, then we push array next. Rest stop push array next. Right, so what this is doing is that we have a next here. We look at the first element and then we look at the next element, which is I +1. But because I +1 is greater than the length, so push -1. And then we look at the next element. So And then we'll look at next element. And the next element next is the current index plus 1, which is 5. So we compare to 5. And because this is less than 5, then we push the next index. So this will push 5 here. And then we look at the next value. And we look at to the right side. If it's greater, for example, assuming this is 2, right? If this is 2, because this is not less than, because this is not less than that. After push, we just break out. Because this is not less than that, nothing happens. And since next is still less than length, we do a next plus plus. And then this will compare again. So next plus plus, next one will be 5. So 3 will compare to 5. And like that. Since we are pushing, we're pushing the value -1, 5, push. So we just return reverse. Bang. Accepted, submit, accepted, yeah. Nice! So that's the whole algorithm here. Wow, stack the length. Stack with -1. Stack the pop. If this stack length result is equal to stack the length -1. That's the last element in the stack, and you push to array I. Okay, what they are doing is initial anti-array on a stack. Traverse the inputs. You push to the stack and end the result. And then you push to stack again, you add result. Oh, I guess this will be more efficient. Okay, because every time when something gets popped, that means the left item is greater than the right item. Like in this case. So next time when they do a compare, they basically skip this element. In my case, I was looking all the way to the right side until you find a bigger element. But that would be more efficient. So we keep using stack. Result is fine. Alright, so they're traversing through here. Oh, if stack is no empty, you modify stack result at the current index. Oh, that's why they fill it with -1. Okay. So if I keep this, if I keep whatever they had in the beginning, and we just not use resolve, the while we traverse from the right side, instead of doing this, while stack dot length then if stack is no empty and the item at the top of the stack is less than both stack length -1, if the top of stack is less than the current index that we're looking at, the ray I, then we do stack.pop. If so, we keep doing this until we hit something that's greater than the array I. If we hit something that's greater than array I, that means the top item of the stack. That means the top item of the stack is greater than the index value. So in this case, if stack.length, that means we want to update array I equal to stack at the, and then stack dot length -1, the topmost item, and then at the end we just push stack dot push array I, and then we return the result. So this should be the same. Length is not defined. Stack dot length. Oh, stack dot length -1. -1이거든. While stack dot length and stack, the top value is less than 9. If the top value is less than 9, then we pop the top value. And if stack.length, if there's remaining items in the stack, then array I becomes the top item of the stack. And then we push the stack array I. negative, -1. Eh? console.log stack 5 なんで So stack is empty. This will get skipped. This will get skipped. And this also gets skipped. There's nothing. So rate up. So this will remain at 1. This will remain at -1. So stack push array I. Array I is 5, so you push 5. While stack dot length. Array is now 4. It's now 4. So stack 5 is not less than 4. So this gets skipped. And if stack dot length, so 5 is something, right? So array I, which is 4 here. Oh wait, rest I. Damn it. Expect -1. 6. Oh, less than or greater than. Next. Okay, we basically shaved 0.006 milliseconds from doing it this way. Next. Given a stack, solely using only stack operations, push and pop. You can use an additional temporary stack, but you may not copy the element into another data structure, such as array. What do you mean such as array? Stack in JavaScript is an array. The value in the stack are to be sorted in descending order with the largest element on top. So this amount sorted using push and pop. Temporary stack. $34, $31, 98. Using only push and pop. Tempt and stack. So we look at the first element. We push that to 10. We look at the next element, and we can compare these two. If we compare these two, 31 is less than 98. Then we pop 10 and move it to stack. And then we push 31. And then we look at next element. If 3 is less than 31, we pop 31 and push 3. And we look at this. But then if we look at this is less than. This is greater than 3. If this is greater than 3, I will push this value. You only use stack, yeah. The requirement is only use stack. Otherwise, I just sort this thing. If you can sort it, then it's much easier. While 10th length, we're gonna take the first value. I'm gonna take the first value. We take the last value. Compare this last value. If this is greater, then we pop this, slot this in. And then we'll put this back in. Remove this. 3 is less than, we just add it. But how do you do this in programmatic way? Because if assuming we have another value here, let's say it's a smaller value. Oh, it's Tower of Harroy. You mean something like the tower thing where you put the circles? If you can move this and move this. Alright, so we have a 98. We put 98 here. And then we look at this value. If this is empty, then we put 98 here. And then next we have 31. We put 31 here. And we look at this. 31 is less than. Then we put 31 here. And next we'll look at 3. Next is 3. We'll put 3 here. And then 3 move here. Next is 34. 34, we put 34 here. 34 is less than 3. And 34 is greater than 3. So we move 3 up here. Now we look at the next value. If the next value is greater than 33, then we move the entire stack over. Okay. So for let I equal to stack dot length minus 1, I is less than, I is greater or equal to 0, I plus plus. So we need 2 temp stacks here. Resolve is equal to this. If result is dot length is 0 or stack at I is less than stack at I is less than resolve dot length minus 1. If the stack is less than the top of the stack, then it's safe to just put that stack on top. So rest dot push stack at I. So that this is the basic. If the value is less than, we just push there. Otherwise the value is greater than. Else, while stack I is greater than resolve at resolve length minus 1, while the current value is greater than this, we need to pop the stack, pop the result. So temps dot stack dot push temp dot stack dot push result dot pop. Right, so whenever we encounter something that's bigger, what the heck? I got kicked. So we have the array we have a 10. And then we have result. So 34, 3, 31, 98. So if we look at the first value, since result is empty, we push that to the first value. We look at the second value, it's less than result, so we push that. We look at this, also less than, we push that. And then we look at this, because this is not less than. We pop this value and put it here. And we look at that again, it's still not less than, we pop this value and put it here. And then we look at it again. Since now it's not, then we insert this value. And then we merge. So we went to the merge. And then I can merge in the reverse order. If we merge in reverse order, the next time we do a compare, it's gonna pop this again. So instead of doing merge, we can compare the 10th value. If 10 is empty, we push to 10. Oh, this is making my head hurt. If 10 is empty, we push to 10. Then we compare 10th. If it's less than, we push 10 to there. If temp stack dot length, if temp is empty, we directly push to result. Stack I. Focus C is here. Because the top value must be the greatest value. Why? So this will be the same, but except this time we're looking at the temp. So stack I is less than and temp dot length. That will push result to temp to stack. Otherwise, so if temp is 0 or stack I is less than 10 or stack I is greater than 10, then we push to result. Otherwise, resolve dot push temp stack dot pop. Otherwise, while let's temp equal to temp stack dot pop, we pop the topmost value. Is this pre-recorded? No, it's not pre-recorded. The fact that I'm answering your question means it's not pre-recorded. Oh, my brain hurts. Guys, my brain hurts. This is hard. Oh, why does every company nowadays need you to do these brain challenges? While 10 equal to 10 dot pop is greater than stat guy, do we even need to do this? Greater than stat guy result dot push 10. After you done that, you just 10 stack dot push array I. This sounds very wrong. At the end, we just do a at the end, how do you merge two arrays? At the end is 10 stack and resolve and reverse. It sounds so wrong. Out of memory, of course. I got kicked again. If temp is 0, the first value temp is 0. So we push result to there. Oh, in this case, temp will always be 0. Because we are not pushing anything to temp. So what if we push to 10 stack right now? Is that doing else? After we're done with this, we do a while. Temp is undefined. Let temp. Yeah, this is wrong. This syntax is wrong. while 10.pop is greater than. One, two, three, four, five. If 10 is empty, you push 5. Yeah, why is this an easy question? Why is this easy? Like, this problem can be solved using temporary stack as auxiliary storage. The algorithm takes the input stack and sort it using a temporary stack, temp stack. The sorting process is done by continuously popping elements from the input stack and push them into the temp stack in sorted order. Rearrange the elements as necessary until between the stack until the original stack is empty. This algorithm is last in, first out nature of a stack. It removes elements from the original stack one by one and uses a second stack to keep the elements sorted. If the top element of the sorted stack is larger than the current, it moves large back to the original stack until it finds the correct spot, at which point it pushes the current. If it's larger, then it moves the larger stack back to the original. At which point it pushes the current element to the sorted stack. Because of this, the smaller elements end up at the bottom of the sorted stack and the larger elements on top, resulting in a stack sorted in descending order from top to bottom. Enters a loop that continues until the input stack is empty. In each iteration, it pops the top element from the input stack Then it enters another loop. It continues as long as temp stack is not empty and the top of temp stack is larger than temp. In each iteration of this inner loop, it pops a tie element from temp stack and pushes back to the input stack. After the inner loop ends, he pushes temp onto temp stack. The inner loop ensures that temp stack is always sorted in descending order, with smaller elements at the bottom and large elements at the top. Once all the loop ends and the input stack is empty, temp contains all the elements originally in the input stack but sorted in descending order. So 5, 4, 3, 2, 1. And then we have temp. We pop 5. 5 is entered here. 5 is pushed. And then we pop 4. 4 is less than 5. You pop the toy element from the inputs. If the top stack is larger than temp, if this is larger than 10, so 4 is current 10, if this is larger than 10, it pops the 10 and pushes it back to the original stack. And then 4 becomes here. And you 3. And then you pop 3. You look at that. Because 4 is larger than 3. You pop 4 and then push to the stack. And you move 3 over. Oh, I guess that makes sense. Okay. So, only using 2 stacks. While we loop until while stack dot length the val equal to stack dot pop if temp stack is dot length is np or If temp stack dot length is empty, for the val is greater than the valve is greater than temp stack, top of temp stack. So length -1. Then we do temp stack dot push val. Otherwise, we popped. Oh, this is pop. Otherwise, we stack dot push now. We push the val back. And then use return temp stack. It's just wrong. Length is not defined. Temp stack dot length. Right, if temp is 0 or the value is greater than the temp value, is greater than the top of temp, then we push that to temp. Otherwise, the value is less than. Okay, we don't even need to pop. Don't think that matters. Stack dot length -1. If the top of stack is greater than the top of temp stack, then we can do stack dot pop. Otherwise, we stack push temp dot pop. 1. No. So initial stack top to bottom. Temp is empty. You pop 23 from the top. Temp is empty, so you push that to temp. And then you pop 92 from the stack. Since 23 is less than 92, you push that to temp. Next, since 92 is less than 98, you push that. .98, so push 98. 31, pop 31 from that. Move the element from temp stack into stack until the corresponding position is found. So 31 is less than the top element, right? And then you pop the top element, you push it back to input stack. You look at the next element. If it's still greater, then you pop the element, you push back to the inputs. And then you look at the next one. If it's less than that, you push this. And then you do this again. This is gonna move 92 back here, 98 back here. So you pop this value. If this value is greater than the top value, you push this value. If this value is not greater than top, while no, if it's not greater than else, while temp stack dot length max the top element, while the top element so this is looking at temp stack. If it's greater than you push, if the top element is greater than val, then inputs, not input, then you put it back to the original stack. So stack dot push stack dot top, and then after you finish popping and temp dot stack dot length is greater than 0. After you finish popping, then you push. Stack dot push val. Yes. So this can be simplified. So it's all done this. We can do I think this whole thing can be removed and it still be the same. Run? Yeah. Submit? Yes! Oh my god, that was so easy. So while so we pop the top element from the input stack, and if the top element is less than, so if the temp stack has top element of the temp stack is greater than the top element of the input stack, then we push the top element from the temp stack back to the input stack. We push that until the temp stack is either empty. If it's empty, then we push the top stack to the temp stack. And if it's not empty, because we are moving the highest value from the temp stack back to the original stack until the remaining top value is less than the current top value of the input stack. So then we move that over to the temp stack. And since we are moving from the top value, which is the highest number, pushing them back to the stack if it's not, then the top element is always gonna, like, if we have that operation twice, so it will push, you push the highest element and then you push the second highest element. So if we do the operation from the time stack back to the input stack, that means the input stack is kind of sorted. The top, whatever element that's removed from the time stack is kind of sorted from the biggest number at the bottom to the less biggest number. So next time when we pop, it will be the second less biggest number. So for sure you will be able to go into the time stack. And then next time we pop, which is what until the first element that was moved from time to the inputs, which is the because this is a first in last out. I mean, last in first out. So if we reverse that, it will be first in last out. First in last out, because last in first out is handling the highest value. If it reverse that, it will be handling the lowest value. So the last element that was reversed from the temp is always gonna be the highest value currently exists until we hit another higher value. Until we hit a smaller value in the input stack, then we start moving from the temp, start popping the temp stack again until we can slot that smaller value into the top of the temp stack, which is the current highest value in the temp stack, and where the input is sorted again. Okay, it's hard to like explain, like kind of how to visually do that. So 23, 92, 98, 31. Right, we have a 10 here. So first we 25. We pop this. This is empty, so we move here. Then we pop this 92. Because this is well, shit. First in, first out. Last in, first out. So 33 will be here. Whoop. And then 92 will be here. And then whoop. 98 will be here. And then look at that. And then 31. Because 31... because the value of 31 will be at a temporary storage right now. So the value is 31. Whoop. Right? Because 31 is less than 98. We push 98 back to this stack. And we compare the next value. Because 31 is still less than this, we push this value, 92. And then we look at next value. And 23 is that, so we move 31 over. So next operation again, we are doing this until the input is... This is the input. We're doing this until the input is empty. So next we're gonna pop this, 92. Value is 92. This less than, so you push 92 here. Remove this. And then next you look at 98. You move 98 here. And then compare this, you push 98. At this point the input is empty, so you just return this stamp. So that's the algorithm. Oh my god. Do you guys like the brain fuck moments? I'm getting brain fucked. Anyways, I need to rest after all this, I don't know, brain fucked moments like this. See you guys next time. Bye bye. 雅思族破门而开，之间谦虚半步，一人曾去目，孤行伫立待的日月当正中，等教问句残花乎？低沟难辨是非，唯有墨鱼之术，盘中人皆得正业乎？耳听闻情伤风骨。生者一寸，一方便言和，一对对正主，有下人无语。红雀飞鸟唯有一人卡夫，对月相连，和手指相互，都是在无心日出。横听手指点那勾着